So do we remember how to do mesh? Yeah. So first step is going to be to define currents for each mesh. So let's say that's I1, I2, I3, I4, I5, I6. So we have 6 meshes. We're going to need 6 mesh equations and then however many dependent variable equations, right? That should be sort of our first observation there. Yeah, so then we're going to look for super meshes. And like Brandon said, we are working with 2 of them. This is 1 super mesh, and that's 2 super mesh. So let's start with our first super mesh. Let's begin with the constraint equation. This is I1 and I2 super mesh. So our constraint equation is going to be what?
I3 minus I1 equal to, does that say 75?
Yeah, 75. Good job. Yep. Current entering minus current leaving equals the value of the current source. Right? Now we need our big KVL that goes around the entirety of this super mesh loop, omitting the middle branch. Right? That's the big key there. So let's start writing our equation. Yeah. Let's call it IZ. Yeah, so I3 is going the same direction, so we're going to subtract I1 from I3 and set it equal to 75.
Like, if you do, let's do a KCL at the top. Like, usually, like, if you want to try, like, if you do I1 going into the top, the junction, right, and 75 milliamps going in there, I3 leaving.
Yeah, so I mean, let's write out the KCL. Okay, so you have 75 entering, and then you have I1 entering, but it's a mesh current, right? So this current isn't just I1, it's I1 minus I2. So that's why it's like KCLs get kind of ugly with mesh currents because you have 2 different current variables for every single branch if it's connected in between 2 meshes. But even if you were to do the KCL, it still would work out to it being I3 minus I1. You just look for the current that goes in the same direction as that current source. And that's going to be your positive current, which is I3, and then you subtract the current going the opposite direction, I1. Yeah. Okay, so now back to our big sort of KVL around the super mesh. We're starting at the bottom left here and going clockwise. So we're going to start with negative 26IZ. That's a Z. It's, I think it's actually 2, but I already defined an I2, so we can't have the same variable. So I'm just going to call it IZ for the sake of demonstration. So negative 26 IZ, and then we're going to do plus I1 minus I2, 61 ohms, plus I3 minus I2 times 92 ohms, plus I3, 89 ohms, equals 0. Does that make sense? Do we know how to do KVLs given mesh currents? A good rule of thumb is as long as you're establishing all your mesh currents to be going the same direction, it's always going to be the positive, whatever mesh that you are in is the positive term for the current, and whatever mesh is adjacent to it is going to be the negative term. So just general rule of thumb. So yeah, okay, that's gonna be the two equations that we need for our first super mesh. So now let's just take a look at our second super mesh, which is for I5 and I6. So our constraint equation this time is gonna be what?
I5 minus I6 equals
Yeah, I6 minus I5. Yeah. You get that, Brandon? Yeah, just the opposite way is how you said it. Should be I6 minus I5 equals 49 milliamps per volt Vx. And now we need to do our giant KVL for that super mesh. So again, I'm going to start on the bottom left. And so it's going to be I6 minus I4 times 60 ohms plus I5 58 ohms plus 38 volts plus I6 times 34 ohms equals 0. And that is our second equation for our second super mesh.
That says 38 volts.
Not 36.
Oh, it's a very chopped 8, but it's an 8 nonetheless. This is, the engineering way. You just get a little lazy with it. Very astute observation. Okay. So we have 4 equations, but we have 6 meshes, so we're going to need 2 more. And naturally, those are going to be for the last 2 mesh currents that we don't have an equation for. I3 and I4. Oh, wait. This is wrong. The first super mesh is for I1 slash I3. So we're missing I2. Okay, so our equation for I2 is just going to be I2 times 33 ohms plus I2 times 46 ohms minus negative 2 volts. So plus 2 volts. Uh-oh. I'm sorry.
Bro, this was all $3.
Yeah, I put you on game.
Yeah, for real. I'm blowing
So y'all don't make money on this match.
Maybe like a couple dollars. Nothing. For a while we would lose more money than we would get because people would steal. But now there's cameras, so don't do that. Okay, so plus, now it's I2 minus I3 times 92 ohms plus I2 minus I1 times 61 ohms equals 0. That's our equation for I2. And now we need our equation for I4, which is pretty easy. It's going to be minus 2 volts plus I4 minus I6, 60 ohms equals 0.
So whenever you have a wire, we just treat it as like nothing?
Yes.
Because it's just a KVL.
Yeah. Essentially, we're just doing a KVL around that loop. So if there's a wire there, you just don't run anything for it. Yeah. That's I4. Now we're going to look for how many dependent variables we're working with. So we have one at IZ, and we have one for Vx. Let's start with IZ first, because that's going to be a super equation to build. Just by looking at this circuit, what would the equation for IZ be? Yes. Yeah.
Oh, yeah.
So you kind of treat it like a super mesh constraint equation, right? You just take the current going the same direction as IZ minus the current going the opposite direction, set it equal to IZ. Very similar concept.
I4 minus I3 equals I3.
So IZ is going to equal I3 minus I4. And now for Vx, we are going to do a KVL because it is defined as the voltage between two different points. And we don't have node voltages with respect to anything. So we don't have a choice but to do a KVL here. So we have a couple options, but the easiest is going to be that one right there. Yes. You don't have to overcomplicate it if you don't have to. So equation for Vx is just negative Vx and then plus I2 times 46 ohms minus negative 2 volts. Equals 0. And that's it. Any questions? Good question. So that doesn't show up in our equations or any dependent source for that matter either. So technically you would be incorrect to write an equation for Vy. I don't know if she still does this, but for a quiz that we took last semester, there was a couple of like dummy variables, so to speak, that were put into the circuit that were not on any dependent sources. And the question asked to write the exact amount of equations needed to solve the circuit. So in that case, you would be incorrect to write an equation for Vy.
That was our first example.
Huh?
Very first quiz. If it says solve
Yeah.
the circuit, that means you wouldn't need to solve for everything.
I would argue no. I mean, I say that because of last semester. It was like write down the amount of independent equations that you would need to solve for this circuit, and the variables that were not on dependent sources, she counted it incorrect to include those into the amount of equations that you need to solve the circuit. So based off of my experience with Deepa, no, you would not need to solve for Vy to solve the circuits. But that is a good question. I'll see if maybe I can get some more clarification on that tomorrow during my meeting.